I welcome you to another chemistry class. Let me ask, how is it going with your chemistry journey so far? I want to believe that you're giving it all your best. I welcome you to Eko's Learner Support for WAEC and NECO candidates. This is a program designed to help you to accelerate in your studies. Today's class is going to be very interesting. I am your instructor, Rashid Juma. If you're ready, then let's dive in.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
All right, you remember that we have a class where we look at Iupac nomenclature, how inorganic compounds are named. This lesson is the second part, and we will be concluding that topic here. Remember what we said in the first video, where we were able to name ionic compounds by actually naming the first element and the second element changing its name to accommodate height. For example, in sodium chloride, we have sodium, which is the metal, and chlorine, which is the non-metal, to form sodium chloride. So I welcome you on board, and we will be flying very high. I hope you're ready. Fasten your seatbelts, and let's have a wonderful time together. So take your notebook and write the topic down and today's dates. We have set the following objectives to guide our instruction today. 1. By the end of this lesson, you should be able to define what a polyatomic ion is and write the names and formulas of the most common polyatomic ions. 2, you should be able to name what we refer to as ternary ionic compounds using the Iupac nomenclature. 3, you should be able to name polyatomic acids such as H2SO4, HNO3, and even H3PO4. To guide us further, we have some keywords that I want you to take note of. You might even check up them in your dictionary. We have oxidation number, which is usually the charge possessed by an atom. Polyatomic ion, which is a crucial part of what we'll be discussing today. The word poly there means many, then atomic means that it has many atoms. And of course, we have radical. A radical is a group of atoms possessing electric charge. Let's look at our icebreaker activity. Think about any chemical names you already know. And pause this video, type your response in the comment section. What are some chemical names that you already know? I'll give you a few minutes to quickly do that.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
You're welcome back. I hope that you are able to name some chemicals around you, especially in your homes. Did you say you were able to identify table salt, which is sodium chloride? How about chalk? That is calcium triisocarbonate 4. How about baking soda? That is sodium hydrogen triisocarbonate 4. Okay? There are so many more chemical compounds that you have around you that you can easily name. And that's exactly what today's class is going to help you to do. Now, you must have your periodic table by now, because I have said your periodic table is a very important tool. Always keep your periodic table handy. You should have it in front of you always, especially when you're learning chemistry. Remember that metals on the periodic table are usually positioned to the left. while the non-metals are found to the right. The transition metals are usually in between the main metals and the non-metals. And that is the periodic table for you there. These are the metals. You have the non-metals to the far right, and then the transition metals are in between them. Now, what are covalent compounds? Because part of what we will be doing today is naming covalent compounds. A covalent compound, of course, is a compound that is formed between two or more non-metals. The emphasis is on non-metals. When non-metals come together, the type of bonding they form is covalent bond. An example is carbon 4 oxide. You can see the two dogs here. Okay? Before sharing, each dog has a bone. And by the time they come together, they were able to share, okay, a pair of what? Of bone. This is exactly what atoms do. They come together, pair their electrons, and they form new bonds. So for example, this is a covalent bond, a bond that is formed as a result of sharing. Isn't this interesting? Let's go. Now, how do you then name covalent compounds? The rules are very simple, and I want you to pause this video right now, write these rules down as we're going to be using them going forward. Have you done that? Excellent. Rule number 1, name the non-metal that is furthest to the left. Remember that covalent compounds are usually formed between two non-metals. So the one that is furthest to the left should be the first one you name, and name it by its elemental name. That is just by naming it. If it is carbon, then it is carbon. If it is nitrogen, it is nitrogen. The name doesn't change. Then calculate the oxidation number of that particular element and indicate what the figure is in Roman numeral. Put it in parentheses, or what we commonly refer to as brackets. 3. Name the other non-metal by its elemental name, but this time you are going to have to modify its name by adding the surface height. Let's put that into practice. Name the following covalent compounds. The first one is CO2. Okay, so let's go now. CO2. That is the compound that we want to name. All right? Now, the first element we are going to name is the carbon. The carbon, the C there stands for carbon. Okay? So, the first part of this name is going to be carbon. The next part of the rule is that we must find what is the oxidation number of this carbon in this compound. And if you refer to our earlier video on how to calculate oxidation number, and you would be able to calculate the oxidation number of carbon here. But let me quickly demonstrate that to you. Okay, the sum of the oxidation number of this is going to be equal to 0, and since we want to calculate carbon, okay, oxidation number of oxygen is -2, and there are 2 atoms of it there. You have carbon plus times minus, minus 2 times 2, 4 equals to 0. And moving -4 to the other side, our carbon becomes +4. And so, the name of this compound is writing the first element as it is, which is carbon, indicating its oxidation number in Roman numeral in parentheses. Okay, there's no space. Don't make that mistake. There's no space between them, okay? And then, since our carbon here is 4, we are going to put 4. Remember, in Roman numerals, okay? Then you close your parentheses, and the second element here is oxygen. So oxygen will then change its name to accommodate the surface height, and that will become what? Did I hear you say oxide? Fantastic. That's exactly what it's going to become. And that becomes carbon 4 oxide. Yeah, you just said that, wow, that's how the name of carbon 4 oxide was derived. It's exactly this way. It's because the oxidation state of carbon in that compound is +4, and that's why we call it carbon 4 oxide. Let's move and look at others very quickly. Okay? Now, the second one is N. That is N2O. Okay? Like I shared a very fast tip with you in the earlier video to be able to calculate the oxidation state of nitrogen here. Since oxygen is going to be -2, and then the nitrogen is therefore has to be what? +2, so that +2 minus 2 becomes a 0. But don't forget, there are 2 atoms of nitrogen here, and so you'll be dividing that by 2. So the nitrogen here is going to be what? +1. So the name of this compound is nitrogen. That's the first element. Put in parentheses, nitrogen what? 1. Roman numeral oxide, nitrogen 1 oxide. Can you quickly name the third one? Try it and let me know how you fare. Very good. So let's look at it together. Okay, the oxidation state of carbon in the third one here is going to be what? It's going to be +2, because oxygen has to be -2, and so the carbon has to be +2. And that means the name will be what? Carbon 2 oxide. Carbon 2 oxide. Okay, how about the fourth example here? Okay, oxygen here is going to be -8. That's -2 times 4. And then this has to be +8. +8 divided by 2, that will be what? +4. And that will be what? Nitrogen 4 oxide. Nitrogen 4 oxide. How about the fifth one here? The first element there is what? Is carbon. Is carbon. All right? Now, there are 4 atoms of chlorine here. So, to indicate that there are 4 atoms of chlorine, you are going to introduce tetra. Tetra in science means 4. So, that will be what? Carbon tetrachloride. Chloride, because the chlorine will change its name to chloride. This is really very, very interesting. So this is how you name covalent compounds. I hope that now you have mastered the rules and you can go ahead and name as many covalent compounds as you come across. Let's then move to another part. So let's look at, but this is an exception. There are few compounds that have unique names. Even though they are covalent compounds, they have unique names and you just need to know them by their names. For example, H2O is referred to as water, not as hydrogen oxide. Yes, that should have been the name if we follow the Iupac nomenclature, but it is commonly referred to as water. That is the common and the special name which it has been given. Ammonia, NH3. pH3 is referred to as phosphine, and CH4 is referred to as methane, not carbon hydride, methane. So these are few exceptions to the rules that we have just looked at. Now let's switch gears to polyatomic ions. What are they essentially? What do they really represent? Now, when you look at the first part of the name, you have polyatomic ion. So the fact that they are ion means that they what? They have charge. Once you hear ion in chemistry, it means charge, plus or minus. If the charge is plus, you talk about cation. If the charge is minus, you talk about anion. So ion refers to as charge. So it means that polyatomic ions contain charge. Very simple. Now, the second part of the name is polyatomic. Poly means many, just like we have polymer. Polysaccharide. So that means there are many, many more than one atom. So can you now give me a definition for polyatomic ions? Wonderful. That is very correct. Polyatomic ions are ions that carry charge and they are made up of more than one atom. Very good. Okay? So that's the definition for you. So you can just use that to modify what you have already written down. Groups of atoms that act as a unit and have overall charge and one name. They are referred to as polyatomic ions. Most times, they usually end with 8 or I's. The ion is composed, if you look at the ions that we have on the board here, it's made up of carbon, it's made up of 3 atoms of oxygen, and then there is the charge there, the 2 minus. So this is an example of a polyatomic ion. All right, so let's get familiarized to some common polyatomic ions. 1, you have tetraoxosulfate 6 ion, SO4, 2 minus. Please document this in your notes and study it. All right, you have the next trioxosulfate 6 ion, SO3, 2 minus. You have trioxocarbonate 4 ion, CO3, 2 minus. You have trioxonitrate 5 ion, NO3 minus. You have tetraoxophosphate 5 ion, PO4, 3 minus. You have tetraoxochromate 6 ion, CrO4, 2 minus, not Cr7. Okay, heptaoxodichromate 6 ion, Cr2O7, 2 minus. And of course, we have the very special and one of the few polyatomic ions that are positive. We have the ammonium ion. I know what is going through your mind. You're wondering, how on earth are you going to be able to remember these gigantic names? Well, that is why you must stay tuned to watch this video to the end, because we will be unlocking that code shortly. Right? So here we are, the rules that you need to be able to name those polyatomic compounds. I want to write the rules down in your notes, and we will be reviewing them together now. The first one says, name the first element unchanged. That's the first thing you do. The first element that is in that compound, name it without any change to the name. If it is potassium, then it's potassium. If it is sodium, then it is sodium. Rule number 2, leave the middle element for now. Do not tamper with the middle element. What should you do next? Go to the what? The oxygen. If there's oxygen in that compound, go there and indicate how many atoms of oxygen do we have in that compound. And you use prefixes like, if you have 1, that's mono. If there are 2 oxygen, that is di. If there are 3 oxygen, that is tri. If there are 4, that's tetra. And then the oxygen itself is now going to change its name to oxo. So if there are 2 oxygen, that will be dioxo. Yes, that's the trick. Dioxo, meaning that there are 2 atoms of oxygen. If there are 3, what does that become? Trioxo. You're really getting good at this now. If there are 4, that becomes what? Tetraoxo. So you can see how we're building up the name gradually. 4, calculate the oxidation number. Again, yes, again. That shows how important it is for you to be able to calculate oxidation number. And lastly, write the name of the compound, double check, and be sure that you have the correct name. Remember, we're using a convention that is global. A name of a compound in Nigeria will be the same in Canada. It will be the same in America. It will be the same everywhere in the world. And that is the power of the Iupac. So you must make sure that your name does not differ from every other place. Now, let's practice with this. I hope you have documented those rules in your notes. So let's apply. Name the following compounds And the first one there is NH4 in bracket of 2, SO4. So, what is the first part of the name? Yes, you're right. The first part of the name is this, the NH4. And if you remember our previous slide, I said that one of the few positive, polyatomic ion is referred to as ammonium. So the NH4 there is ammonium. So you are just going to write the name unchanged, ammonium. Now, what is the middle element here? Awesome. The middle element is sulfur. So leave it and move to what? To the oxygen part. When you get to the oxygen part, answer this question. How many oxygen are there? You are right. There are 4. And 4, we use what? Tetra. So that is what? Tetra what? Tetraoxo, because we are referring to the oxygen, tetraoxo. Now, we will now come back to the middle element. So the middle element is now going to change its name. We will be adding this suffix 8. So if the middle element is sulfur, it will become sulfate. If it is nitrogen, it will become nitrate. How about if it is phosphorus? Fantastic. It will become phosphate. If it is chlorine, it becomes chlorate. So you are going to have to modify the name of the middle element by adding 8 to it. So the middle element here is sulfur, and that will be what? Tetraoxosulfate. All right, sulfate what? And that's where we need to calculate the oxidation number. If we calculate the oxidation number, the oxygen here will be -8. The ammonium has a charge of +1, and there are 2 of it here. Okay, and you can see to balance the charge, what do you need to add to +2 and take away from 8 to get 0? Very correct. +6. Tetraoxosulfate 6. Yes, that's how the magic is done. Let's quickly apply the same rule to the second compound. Okay, so the first element here is potassium. That is straightforward. Leave the middle element, go to the oxygen. How many oxygen are there in? 7. Yes, 7 in science means what? Heptagon, 7-side shape. So what? Heptaoxo. Now, the challenge here is that there are 2 atoms of the middle element. The middle element is chromium. So what does it change its name to? Very correct. It changes its name, so chromate. But there are 2 of it, and so we have to indicate that with a di, and that becomes heptaoxo dichromate. Dichromate what? We need to calculate the oxidation number. This is -14. This is +2. Definitely this has to be +12. +12 divided by 2, that will be what? +6. Dichromate 6 in Roman numeral. Okay? Now, if you look at the third compound here, the first element is hydrogen, and that is very, very peculiar to acids. All acids start with hydrogen. That is an important point that you need to take note of. So, we are going to have to skip that first part of the rule that says name the first element as it is. You will not name the first element as hydrogen. Instead, you are going to add the name acid at the end of the name. That tells us that it starts with hydrogen. So skip that part, leave the middle element, which is the chlorine, go to the oxygen. How many oxygen are there? Just 1. So you can decide to say monooxo, okay, or just simply oxo, because we know that 1 is oxo, okay. So we can remove the mono, that is oxo, and then the middle element is what? Chlorine, and that changes it to what? To chlorate, ozochlorate. Okay, so we need to calculate the oxidation state of the chlorine there. Oxygen is -2, hydrogen is +1, and the chlorine has to be what? +1. Ozochlorate 1, And then to reflect the hydrogen that starts the compound, we had acid, isochlorate 1 acid. I hope that this has been very helpful. With practice, I can assure you that you will be able to name as many compounds as you come across. Okay? Just move on very quickly to our top 5 exam-style question. The oxidation state of chlorine in NaClO3 is, pause the video right now, work it out, and let me know what is the option that you went for.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Welcome back. So, what is your answer for this first of our top 5 exam question? The oxidation state of Na of chlorine in NaClO3. So like we do, the oxygen is -2 times 3, that's -6. Okay, so the sodium is a group 1 element, that's +1. Definitely the chlorine has to be +5, because +5 + 1, that's +6. +6 minus 6, that will give us 0. And the correct answer is C. I hope you got that right. Amazing. Let's move. The second of our top 5 says, what is the Iupac name of this compound? Okay, Fe2O3. So we need to calculate what is the oxidation state of iron there. Okay, you will see that before this compound was formed, iron itself was +3, while the oxygen was -2. So that has to reflect in the name. And the correct answer here is what? Iron 3 oxide. Never mind the 2 there. The 2 was first belonging to the oxygen before the combination took place. The 3 is actually the valency of the iron. Let's look at the third one. Iupac name for this compound is, try it and let me see what you got. The correct answer is option A, and that is potassium hexacyanoferrate 2. This is actually a complex, what we call a coordination compound. So the correct answer is A. Let's look at number 4. Name the following polyatomic ions. So all you need to do is to turn to the list which you have already written down. What is SO4 2-? That's tetraoxosulfate 6 ion. How about CO3 2-? That's trioxocarbonate 4 ion. How about NO3-? That's what? Trioxonitrate 5 ion. Wonderful. And the last is a true or false question. Polyatomic ions do not get their names changed to end with an "ide." Is this true or false? What do you think? Amazing. Yes, the correct answer is what? Is true. We do not have add "ide" to polyatomic ions. So, I want to thank you for your patience having going through the rules for calculating both covalent compounds and polyatomic compounds. I assure you that if you can keep practicing, you will be able to name many of the compounds that you will come across in your chemistry study. I hope that you have been able to learn something from today's class. If the answer is yes, then meet me in subsequent class.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
But don't forget to leave your feedback, your suggestion, your reactions. They are very important, and we would love to read all of your comments. Keep learning, and God bless you.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.